Textbook title will do. You're going to go back to what we did last time and see if I...
Is it the exact same?
Basically, it's the same dot point.
Right. Do I even need to take any notes?
Probably not, but you should see if you can get there before I do.
Okay.
Try doing the exam and get there before I do. Okay, for example, the paths of two particles with respect to time are described by R, I'm just going to call them R and, can I call them R and S? Or do you want me, I'll do what they do. R1 of time says 2t minus 2i hat plus t squared plus 6j hat, and R2 of time is ti hat plus 5tj hat. So the question is, like the dot point says, do these paths of these two particles cross? Do the particles actually collide? If you like, we might go colliding, question mark, particles. Do the paths cross? Do the particles meet? Well, how do I work out whether the paths cross? Someone other than Rain who's done it before. If it's tech active, what can I do? Graph them, see if they hit each other. Do you know how to do that in your graphics calculator? Get it out and try. Unfortunately, as a parametric equation, the calculator will not give you the intersection. So what can I do about that?
Do it on paper.
Yes, or?
Graph it yourself.
Or, can I turn this into a Cartesian equation?
Yeah.
Remember doing that? So, 1. X equals 2t minus 2, y equals t squared plus 6. Careful, Ben. Rearrange this, plug it in here. Don't rearrange this one for t. Remember? That's what we just talked about this morning. T is x plus 2 over 2. X squared plus 4x plus 4 all over 2 plus 6 half x squared plus 2x plus 8. There's one equation. Do it with the other one, plot them, you can find where they cross. I've done something wrong. I've clearly done something wrong. Somebody should check my arithmetic.
That's what I got on my one, but I didn't even do anything.
Because they don't cross.
Yeah.
So I've done something wrong here.
It's your parameter. It's your yeah. You gotta.
Half x squared plus 2x. 4 and 2 is 2 plus 6. What have I done wrong? X squared plus 4x plus 4. Oh, divided by
4.
4. So a quarter x 7. Okay. Use GC. 1470.
Oh, right.
Could you have got there without the calculator from these two equations?
Yeah.
Like y is 5x. Put 5x here, quadratic. You can factorise pretty nicely, they're nice whole numbers. So you could solve it yourself if you needed to. Okay, the paths cross. The paths cross, but are the particles actually there at the same time or not? Will the particles actually collide? Or does one go past and then the other go past afterwards?
You put them back in and solve for t.
Correct. What time are they at these points? In fact, you can, if you go to the crossing points first, then yes, you can say put x equals 2 in, work out what t is, then check if the y is the same. You can solve directly if you haven't done that first. You can just go, let this x equal this x, solve for t, and then see if they're at the same y coordinate at that time. So there's different ways you can get there. I do it the second way because well, it's basically the same anyway. So if we say 2, or if I just go this equals this, right? So we know the paths cross, but do the particles collide? You can say collide, meet, whatever, depending on what the question asks you for. Let's go. 2t minus 2 equals t. If they're going to collide, they have to be at the same place at the same time. Use the time. If this is true, then t must equal 2. So I can tell you already, they aren't even at 14 at the same time. There's no way to get 14 by equating their x coordinates. They don't meet at 14. But they maybe meet at 2. Let's see what the y coordinates are. Y1 at 2. Is that clear? Maybe I should just say at this time. 1 has a y coordinate equal to 2 squared plus 6. 4 and 6 is 10. And particle 2 has a y coordinate 5 times 2, which is 10. They're at the same place at the same time. Yes, they meet or collide, whichever you prefer, at t equals 2. If you like, at t equals 2 at 2:10. Make sense?